What if you could weld rusty steel, dirty metal, thick structural beams, and even work outdoors in windy conditions without worrying about your shielding gas blowing away? That's exactly why Flux Cored Arc Welding, or FCAW, has become one of the most powerful welding processes in modern fabrication. Walk through any major construction site, shipyard, pipeline project, or heavy equipment manufacturing plant, and chances are you'll find welders using FCAW. It combines the speed of MIG welding with the rugged durability of stick welding, making it one of the most versatile welding methods available today. But what makes FCAW different from MIG welding? Why do industries increasingly choose it for demanding applications? And how are modern technologies in 2026 making flux cored arc welding faster, smarter, and more efficient than ever? In this guide, we'll break down everything you need to know about FCAW, including how it works, where it's used, its equipment, advantages, disadvantages, and the latest innovations transforming the welding industry. Let's get started. What is flux cored arc welding? Flux cored arc welding is a semi-automatic or automatic arc welding process that uses a continuously fed tubular electrode filled with flux. Unlike solid welding wire, FCAW wire contains a core filled with special flux materials that perform several important functions during welding. As the electrode melts, the flux inside the wire creates protective shielding gas, slag covering, arc stabilizers, and alloying elements. These materials protect the molten weld pool from oxygen, nitrogen, moisture, and other atmospheric contaminants. The process generates heat through an electric arc formed between the continuously fed electrode and the base metal. As the arc melts both the electrode and the workpiece, a molten weld pool forms. Once cooled, a strong metallurgical bond is created. Because of its ability to produce high deposition rates and deep penetration, FCAW has become one of the most productive welding methods used in industry today. Why is FCAW called dual shield welding? FCAW is often referred to as dual shield welding because some FCAW processes use two forms of protection. Internal protection, the flux inside the tubular electrode, creates shielding gas and protective slag. External protection, additional shielding gas may be supplied from a gas cylinder. This combination provides exceptional weld quality and protection. Depending on the application, FCAW can operate as FCAWS, self-shielded, uses only the flux core for protection. No external shielding gas required. FCAWG uses both flux core protection and externally supplied shielding gas. This provides higher quality welds and improved mechanical properties.
Modern advancements in FCAW 2026. Flux cored arc welding has evolved significantly in recent years. Modern welding systems now deliver higher efficiency, improved weld quality, and increased automation. Smart welding machines. Modern FCAW welders feature digital displays, automated parameter settings, arc optimization software, memory storage programs. These features help reduce setup time and improve consistency. Robotic FCAW systems. Many manufacturing facilities now use robotic FCAW systems for structural steel fabrication, automotive manufacturing, heavy equipment production, shipbuilding. Robots can maintain perfect travel speed and arc length, resulting in highly consistent welds. AI-assisted weld monitoring. Advanced welding systems now include real-time weld tracking, defect detection sensors, automated quality control. These technologies help reduce costly welding defects before they become serious problems. Improved flux formulations. Modern electrode manufacturers continue developing flux formulations that provide lower spatter levels, better penetration, higher strength welds, improved crack resistance. This is especially important in critical industries such as aerospace, energy, and infrastructure construction. Portable inverter FCAW machines. Older welding systems were bulky and difficult to transport. Today's inverter welders offer lightweight construction, energy efficiency, better arc control, portable operation. This makes FCAW more practical than ever for field repairs and mobile fabrication. Applications of FCAW. One reason FCAW continues to grow in popularity is its versatility. It is widely used across multiple industries. Construction industry. FCAW is commonly used for structural steel fabrication, buildings, bridges, industrial facilities. Its ability to weld thick materials quickly makes it ideal for construction projects. Shipbuilding industry. Shipyards frequently use FCAW because welding speeds are high, deep penetration is achieved, position changes are easier. The process performs exceptionally well on large steel structures. Pipeline manufacturing. Pipeline welds require high strength, deep penetration, minimal porosity. FCAW provides all of these benefits. Heavy equipment manufacturing. Industries producing excavators, bulldozers, mining equipment, agricultural machinery often rely on FCAW for durable welds.
Repair and maintenance. FCAW performs well on rusted metal, dirty surfaces, outdoor repair work. This makes it valuable for maintenance operations. Underwater welding. Certain FCAW electrodes can be used for specialized underwater welding operations. These applications require highly trained professionals due to the challenging conditions. Components and equipment of FCAW. A Flux Cored Arc Welding system consists of several key components. Power source. Most FCAW operations use a direct current DC power source. Common settings include DCEP, direct current electrode positive, provides deep penetration, stable arc, excellent weld quality. DCEN, direct current electrode negative, often used for thinner materials and specific electrode types. Wire feeder. The wire feeder continuously delivers the tubular electrode from the spool to the welding gun. It controls wire feed speed, deposition rate, arc stability. Consistent wire feeding is critical for quality welds. Welding gun. The welding gun performs several functions, conducts electrical current, delivers the electrode, supplies shielding gas when required. Air-cooled guns. Suitable for light-duty applications, lower amperage welding. Water-cooled guns. Used for high amperage welding, extended operation periods. These systems maintain lower operating temperatures and improve durability. Shielding gas. Dual shield FCAW commonly uses carbon dioxide. Benefits include low cost, deep penetration. Argon CO2 mixtures provide reduced spatter, better arc stability, improved bead appearance. Argon with small oxygen additions, used for specialized applications requiring enhanced arc performance. Flux Cored Electrode. The electrode is the heart of the FCAW process. Its hollow core contains flux compounds, arc stabilizers, alloying materials, shielding agents. Different electrode designs are available for specific applications. Types of FCAW electrodes. All-position electrodes, designed for vertical welding, overhead welding, horizontal welding. These offer excellent control and versatility. Flat position electrodes, best suited for thick metals, high deposition rates, production welding. Self-shielded electrodes, ideal for outdoor welding, windy environments, remote job sites. No shielding gas cylinder is required. How does flux cored arc welding work? The FCAW process is relatively straightforward. Let's break it down step by step. Step 1. Power supply. A DC welding machine supplies electrical current to the welding gun. Step 2. Continuous electrode feed. The wire feeder continuously pushes the tubular electrode through the welding gun. Step 3. Arc formation. When the electrode approaches the workpiece, an electric arc forms. This arc generates intense heat. Step 4. Melting the metal. The arc melts base metal, electrode wire, creating a molten weld pool. Step 5. Flux activation. As the electrode melts, the flux core burns. This creates protective shielding gas, slag covering.
Both protect the molten metal from contamination. Step 6. Solidification. As the weld pool cools, the metal solidifies and forms a strong joint. The slag remains on top and is removed after welding.
Advantages of FCAW. There are many reasons industries prefer flux cored arc welding. High deposition rate. More filler metal is deposited in less time. Deep penetration. Produces strong welds in thick materials. Excellent outdoor performance. Self-shielded FCAW performs well in windy conditions. Welds dirty metals. Rust, mill scale, and minor contaminants are less problematic. High productivity. Continuous wire feeding increases efficiency. Easy automation. FCAW is ideal for robotic welding systems. Versatile positioning. Can be performed flat, horizontal, vertical, overhead. Disadvantages of FCAW. Despite its many strengths, FCAW has some limitations. Slag removal required. Additional cleanup is necessary after welding. More spatter. FCAW generally produces more spatter than TIG welding. Higher electrode cost. Flux cored wire costs more than standard MIG wire. Fume production. The flux generates more fumes than some welding processes. Proper ventilation is essential. Equipment maintenance. Wire feeders and consumables require regular maintenance. Safety precautions for FCAW. Because FCAW produces intense heat and fumes, safety is critical. Always wear a welding helmet. Use flame-resistant clothing. Wear leather gloves. Ensure proper ventilation. Inspect cables and equipment regularly. Keep flammable materials away from the work area. Use hearing and respiratory protection when necessary. Modern welding helmets with auto-darkening lenses provide improved protection and visibility compared to older models. Conclusion. Flux Cored Arc Welding, FCAW, has earned its place as one of the most efficient and versatile welding processes in modern industry. By combining deep penetration, high deposition rates, excellent outdoor performance, and the ability to weld contaminated metals, FCAW offers capabilities that many other welding methods simply cannot match. From shipbuilding and pipeline construction to heavy equipment manufacturing and robotic production lines, FCAW continues to play a critical role in today's welding world. And as technology advances through smart welding systems, AI-powered quality control, robotic automation, and improved flux formulations, FCAW is becoming even more productive, reliable, and accessible in 2026 and beyond. For anyone serious about welding, understanding FCAW is essential because it remains one of the most powerful tools for creating strong, durable welds in demanding real-world environments.